Hi, I'm an old guy and I do maths. And today, yet again, we're looking at probability trees and probability in general. So just let me explain what's going on here because it looks fairly busy. We're considering two elements of probability trees today. One is the idea that there can be different probabilities for different outcomes. And the other is the idea of replacement. And I'll come to replacement in a minute. Let's just consider the idea of different probabilities. So let's assume we have a bag, one bag, and in that bag there are two green marbles and one blue. If we were to reach into that bag and choose at random, the probability that we would get a blue marble is 1 out of 3, 1/3. And the probability that we would get a green one is 2/3. That is what is meant by different probabilities. These probabilities, like the first example of probability trees that you might have looked at on this channel, will add up to a total of 1. So the total probabilities for the event, which is this, add up to 1. This is called an outcome, this is called an outcome. Now, that's all there is to different probabilities. And it's quite possible to illustrate those with a probability tree. This is how you do it. Now, the idea of replacement. Let's go down to the second probability tree here. Now, I'll just remind you, we have one bag, two green marbles, one blue. If we make a choice by reaching into the bag for the first time, what we do is we repeat what went on here. 1/3 blue, 2/3 green. Assuming that we pick a blue marble, we can either leave that marble out of the bag or we can put it back in the bag. Now in this case we put it back in the bag and that's what's called replacement. So we replace the blue marble and we make a choice all over again. And the probabilities are therefore the same. Let's say we pick a green marble, we put it back in the bag, we replace it, the probabilities will be the same. So just to run through what the final possible outcomes will be, it can be blue-blue, it can be blue-green, we'll put a bracket around that. It can be green-blue, and it can be green-green. 4 possible combinations of outcomes from 2 choices. Now, what is the actual probability? Well, in this case it is 1/3 times 1/3, which equals 1 out of 9. Here it is 1/3 times 2/3, which equals, where are we? 1/3 times 2/3, 2 out of 9. And here it is 2/3 times 1/3, so it'll be the same result, but the order is different. And that is 2 out of 9. So far we have 5 out of 9. And down here, the probability of green-green is 2/3 times 2/3, which equals 4 out of 9. Now these all add up to 1. So if you want to know what the probability of getting a blue and a blue is, you multiply these and you get 1 out of 9. You have a 1/9 chance. It's the lowest chance. If you want to know what blue-green in that order is, it's 2 out of 9. But if you wanted to know what getting a blue and a green in any order would be, what you'd do is you'd add these 2 probabilities. And they would give you 4 out of 9. I hope hope that's clear. That's as far as I want to go with this. The next in this series will involve different probabilities without replacement. So what you're going to see is you're going to see these numbers change. But we'll get into that in the next video. Thanks very much for watching. I hope you found this useful. If you did, please like and subscribe, and I'll see you next time. Bye.